In this lecture, we'll cover SQL functions for dates and times. Date-time functions fall into 5 areas: functions for creating date-time values, functions for breaking out parts of a date-time, such as hours or minutes, functions for formatting date-time values, functions for working with time intervals, and those for working with time zones. Overall, the functions have an accounting business flavor, and of course, they have the usual flock of synonyms. So let's start with functions for creating date-time values. The most common action is to create a value for the present moment, for instance, to timestamp a purchase. Never settling for one name when half a dozen will suffice, SQL offers multiple synonym sets for this purpose. Functions now, local time stamp, and current timestamp all return a full date time for now, given in the local time zone. Thus, their cousin pairs, current time or cur time and current date or cur date, do so also, but they provide only a time or date value, not a full date time. And in the section on time zones, we'll see yet more functions for now that work in UTC. Now, the other common case is creating a date from an entered string, which you can do with stir to date. Now, the second major area is date slicing. There are a number of functions for getting parts of a date, for instance, the month alone, the hour alone, etc., from a full date time. Functions date and time, for instance, return thus just the date or the time portion of a complete date time. Functions year, month, day, day of month, hour, minute, and second retrieve the individual parts of a date time. And here are some example calls of those, using the time now as the argument, and you can see what I mean there. And then finally, there are several related functions for business-style data, such as quarter, week of year, day of week, day of year, etc. Here is a run of quarter. We're in the 4th quarter in fall here. And then the week of the year, it's the 45th week of the year. So let's move on to our third area here of formatting dates and times. The function dateFormat formats date times, not just dates, but full date times, using a format string of % escapes to specify the output format. For instance, here's a call to format the present time in a slightly interesting way, with now and then the format string and % escapes in it right here, and that's what we get. Now, there is also the more specific time format, which formats only times, and a couple of functions to print the name rather than number of a month or day of the week, e.g. April or Sunday. These are largely redundant, though, since the selection of format specifiers for date format is powerful enough to do all you need. That selection is in the MySQL docs as part of the date format description. There's a remarkably rich set of ways to represent hours, minutes, months, etc., including both numerical and string representations, so either for or April for a month, for instance, 12 or 24-hour times, and so forth. So, a couple of in-lecture questions then. First, look up the format specifiers and use dateFormat to write the equivalent of month name, look up what that is too, of 1776-07-04, and of day name 1776-07-04. Those will give you the month and day of the week, in fact, of Independence Day. And coming back from a pause, the month you can get out of date format with the %M specifier, and that will print only the month from the date, and it will print it as a word. And then to get the day of the week, you use capital %W, thus. And so running those, we find that the month, of course, was July, and the date of the week was Thursday. And now that we're looking at the format specifiers, let's revisit stir to date, as promised earlier. So question 2. Using the same format specifiers as for format date, write stir to date calls to parse the European form date 1.4.2010, 1607. It's in the notes, of course. And also the American form one, April 1, 2010, 4:02 p.m. And coming back from a pause there, we would parse the European date as follows here, with %d.%m %Y for the year, 4-digit year, and then hours, capital H for 24-hour time, and then the minutes, and it'll print the date that is created then back out, but understand that it parsed this string to create that date and then is printing the date in standard format to show you what it got. And the American date will take a different format string, thus, and here we're using %m for the name of the month and %p for the AM or PM designation. And we again get the correct date printed in standard format. Now this brings us to an important subtopic in formatting. Date formatting is highly variable by nation. Most Europeans would write the date from question 1 as 04.07.1776. And Chinese might write 1776-07-04, while Americans would use 0704-1776, which is really kind of odd since it doesn't list time units in ascending or descending order. Also, some cultures use 24-hour time, while others use 12-hour time with AM/PM, as we just saw a moment ago in the earlier question. The getFormat function supplies suggested format strings for different cultures and is worth looking up. It only covers broad cultural areas and is not too precise, but it's a start. So, question 3. Let's try some international formatting here. Use date format to format 1776-07-04. You pass that as the first argument to date format. Format it in American style as July 4, 1776, without a leading 0 on the 4. And format it also in European style as 04.07.1776, and in this case, do it without an explicit format string, relying instead on getFormat. Coming back from a pause, for the first one, in American style, you could format it with %m space %e, which is a date number or day number without leading 0, and then the year, and get that. And then for the European style, you instead format it as and that's what we get. Note we're using getFormat, and then date is the first argument for getFormat, as you should have determined by looking it up, to tell it that you want a date formatting string, and then EUR for European. And in that case, we get this format as expected. Now, the month and day naming format specifiers, for instance, %m, capital M, also work internationally in recent MySQL versions. So question 4, run the following line and do this in your own setup as well. Set LC time names equal to, quote, ES_ES, like that. And then rerun the command to show the July 4th, 1776 date from answer 3, the American form 1. What do you get, and why? Coming back from a pause, if you tried it yourself, then what you should have had is Julio 4, 1776. The LC time names variable determines the locale used for week, day, and month names, and the setting ES_ES is for Spanish. So let's move on now to our next major area of date time functions, and that's working with intervals. adding or subtracting time intervals to a date or time is a common requirement. For instance, computing the date 7 days from now, or the time 15 minutes before a scheduled meeting time. Less common, but still useful, is computing the difference between times. For instance, the difference between a time of login and the present time to find out how long a session has lasted. SQL provides a plethora of functions for these purposes, with the usual synonyms and subtle variations in behavior. So first, adding and subtracting intervals. Functions addDate and its synonym dateAdd, and subDate and its synonym datesub let you add or subtract an interval to or from a date time. The date in their names doesn't preclude their use with full date times. Intervals are specified via yet another special parameter syntax of the form interval and then number and unit. For instance, interval 1 hour or interval 15 minute. The units are never pluralized, by the way, regardless of their number. You can look up the allowed units. There's a full set from seconds all the way up to years. So the 4 interval adding and subtracting functions we just mentioned take a date time and add or subtract an interval. So 15 minutes from now, for instance, would be add date now, comma, interval 15 minute. And at this point, that's 10:42 in the evening. You may use negative interval counts, so 1 hour before now could either be add date now interval minus 1 hour, or if you like, you can do the equivalent subdate and get the same effect. That's more SQL redundancy going on there, I guess. Question 5. Write SQL that gives the time that is 1 second less than a year from now. Now, don't do a lot of math for this. It's easy if you do nested calls. And coming back from a pause, if you thought it through, you could do a nested arrangement like this, where we would do a inner add date of now interval 1 year, and then take that as the argument for an outer subdate of interval 1 second, and get the time exactly 1 year less 1 second from now. Now, as question 5 shows, adding or subtracting more complex time intervals using the interval-based functions requires either multiple calls or a computation of all intervals in a least common denominator unit, like seconds. For instance, we could have done question 5 by adding 31,535,999 seconds. It's 1 less than a year, but that's pretty tedious. So if you want, you can add or subtract a general time amount, for instance, 12 hours, 34 minutes, 45 seconds, with functions addTime and subTime. For instance, a time 23 hours, 59 minutes, and 59 seconds ago would be select subtime now 23, 59, 59. Thus, you can also use hour values that are larger than 24, as long as you don't exceed the range of a time column. So up to now in this section, we have talked about adding or subtracting intervals. But what about finding a difference between date times? Expressing such a difference is a bit problematic. If it's within the range of a time, it could be expressed as such, and method timeDiff does exactly that, returning a time difference between 2 date times. But differences larger than 840 hours get truncated to 840 hours, predictably. DateDiff works for larger differences between dates, but returns a difference as an integral number of days with no time component. And so question 7 here. What if I do a DateDiff between dates with a time component? Does it round up the difference? Does it truncate it? Either read the docs or do a bit of experimentation to figure out the rule. How close can 2 date times be and still be a day apart? If you experiment around with it, what you'll find is that It's coming back from a pause, sorry. If you experiment around with it, you'll find that date diff simply drops the time component, truncates each date effectively to midnight at the start of the day in question. So 23:59:59 is 1 day away from 0:00 of the next, even though the two times differ by just 1 second. Here, for instance. And there's a -1 day difference because the first is a lesser day. Now, more recently, SQL has added a timestamp diff function that returns a difference between two date times or timestamps as an integral number of any unit you like, with the unit as a first parameter. If you want a difference in hours, for instance, you could write select timestamp diff and then hour as the first parameter and then the two timestamps or date times, and it'll tell you that they are 5 hours apart. Timestamp diff truncates any fractional difference in the unit in question. So if there were minutes, as there are here for 1750, those are dropped. And so we come to our final small section here, which is working with time zones. There is a group of date-time functions that deals with time zones. First, we have UTC date, UTC time, and UTC timestamp, which return the current date, time, or full date time in UTC. As you can see, looking here, suddenly I'm dealing with the next day from the day that I've been showing you earlier. It's tomorrow at 6 in the morning in Greenwich at this time. And then to go with them, we have convert TZ, which takes a date time and a from time zone and a to time zone expressed in string form and converts the date time from the first time zone to the second one. So, for instance, if we're in Pacific time, then the call convert TZ, UTC timestamp, then from UTC to the time zone US Pacific gives us the same outcome as now. You can look up the time zone names in the mysql.timezonename table. Now, you may need to follow documentation instructions to get this table in the MySQL database properly configured and populated. But once it is, here's the kind of thing you'll get. A huge number of possible different time zones. Now, the presumed current time zone is given by variable time_zone and can be set thus, with this being the new time zone. Let's use US Eastern, for instance, and we'll find that we've now shifted to 1 o'clock in the morning, since that's what it is currently on the East Coast. Now, this will affect the times given by all local time zone functions, and the setting lasts for the current session. There are ways to set it permanently for the server if you like. Check the docs for those.